Alrighty. Oh, yeah. Alrighty. Okay, so today's integrating factors. Um, Give me a second, though. I gotta cut my dang nails, bro. I cut my dang nails. Guys, I learned something crazy. Leonard Euler, of math fame, had 13 kids. Shh, 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 shh. Okay. Okay, so integrating factors for linear equations. So last time it was basically just get. This time there's a really cool symbolic trick that you do. Okay, and we'll go into the trick right now. So remember that a linear differential equation, that's non-homogeneous is of this form. So y prime equals a of t times y plus b of t. This should look exactly like y equals mx plus b, or if from linear algebra, ax equal to b for the fixed points rather, or ax plus b. And again, the terminology is the same. In linear algebra, if you have ax equals b and b is not equal to 0, then that's a non-homogeneous linear a linear equation. I don't know, linear system of equations. And if b is 0, then you call it homogeneous. So we get the same thing here. And what you'll see is that there actually is some backing on why it's called linear. I mean, you do end up getting a subspace. So essentially, last time we were talking about the properties of linear equations. And if we have a homogeneous linear differential equation, then for any solution, then a scalar multiple of that solution is also a solution. And that means that that scalar multiple could be 0. So the 0 is always a solution of a linear homogeneous differential equation. And we also can show then that for any two solutions to the homogeneous equation, that their sum is also. So it truly is like a linear subspace or whatever. I mean, it is a vector space. So the linear is not just some like weird name, but there actually is some reasoning behind it. All right, we're gonna lock in today, guys. We're gonna lock in, do a bunch of math, and just bang this stuff out. So how can we go about finding the general solution? There's a crazy trick, and they sympathize with the fact that it's like, how the heck would you come up with this? So the first thing we do is we take this and we invert a by multiplying it by -1. So we just move it to the other side, but make it a plus. Okay. Then their whole thing is like, if you squint at it, if you take some stuff out and leave some stuff in. So I'm gonna write all this down because we went over this yesterday, and it's still kind of wild to me. So if you have y prime plus g of t y equal to b of t, if you squint at it, and we were to say, that this sort of looks like a product rule. It's just missing some stuff. So just to remember the product rule. If we have u of, and I'm not going to call it mu because it's too annoying to write the mu's. So I'm just going to call it u. U of t, y of t, and we take d dt of this. It's going to be equal to u prime y plus y prime u. Okay? Okay. And the way that these look similar is we have a y over here, just like here, and then we have a mu here. So the problem is that we don't have, okay, wait, we don't have the mu there. We do have the dy dt. So now what we do is we actually just multiply. So this is actually so clever. So in order to get this u of t on over here, we just multiply everything by u of t. So in our total equation, we had y prime plus g of t y is equal to b of t. And we multiply both sides by u of t. And then we get u y prime plus u g y is equal to bu. And then the cool part about this is that if we can find, okay, so here they multiply this out, okay? But now the cool part is that if we can find that that this u of t, g of t is actually du dt, i.e. this, the new differential equation is just, okay, wait, let me read this. Multiply both sides of the original differential equation by an unspecified function mu. All right, we get this. This all makes sense. The left-hand side looks even more like the derivative of a product of two functions. For the moment, let's assume that we have a function u of t so that the left-hand side actually is the derivative of the product ut times y of t. So suppose we found a function that satisfies this, then the new differential equation, right, okay, so this is the step of like explaining why it simplifies. So if we have this, then this, where d dt of u y is equal to b u, right, b u, then this is our new dE. So if we have that, then we can just rewrite that whole left-hand side as the derivative. And then the important part from there is, now that we have d dt of uy equal to bu, we integrate both sides, dt, integrate dt. And then, so by the fundamental theorem of calculus, I believe, we just get uy is equal to the integral of ub dt. Okay, so then, finally, the full solution is y of t is equal to 1 over u of t integral u of t times b of t dt. So this is the solution. So now that does assume that we can integrate this product. Okay. Okay, so now that we've seen how this might help, we want to figure out how to find it. And this amounts to just solving the differential equation. So we apply the product. Okay, so let's go back to so now finding u of t. We go back to d dt of uy is equal to u y prime plus u g y. Then we get u prime y plus y prime u is equal to u y prime plus u g y. And we want to figure out how to cancel this out. So if we subtract the uy primes, the uy primes cancel. Then we're left with y prime u is equal to u g y. We can cancel out the u. Oh, wait. I did this wrong. No, we get u prime y is equal to ugy. We can get rid of the y. So now we get u prime is equal to ug, which is what they have here. Okay, so once you just simplify it after expanding the product rule, we're all good there. Okay, and so to solve this, we know it's just going to be u of t is equal to x integral g of t dt. All right, and that has a name. This is called the integrating factor. Okay, now that we've done some of the notes, we got to get back to practice, because practice is where I'm gonna really like. For me, it's all about the practice. Otherwise, I just can't remember it. Because there's kind of a lot going on, right? There's like the justification. Note that when we calculate u of t, there is an arbitrary constant of integration in the exponent. Since we only need one integrating factor u of t to solve the equation, we usually choose the constant to be whatever is most convenient, and that choice is usually... Okay, I was wondering about that. Okay, so let's do an example. Okay, y prime plus 2 over ty is equal to t minus 1. So this is an example. And if, so a of t is equal to 2 over t, or this is g of t, actually. I'll stick with the g. G is fine. And then b of t is equal to t minus 1. Okay, so what we're going to get is u of t, or what we're going to get is u prime is equal to gu Okay, so that means that we're going to get one du over u is equal to g dt, which is equal to u of t is exp of ln or 2 ln of t, because the integral of 2 over t is 2 ln t. So this is equal to exp of ln t squared, and the ln and the exp cancel, and you get just u of t is equal to t squared. Did they get that? Yeah. U of t equals t squared. Oh, oh God. Okay, now that we have mu of t, we want to multiply both sides by it. So we want to go t squared y prime plus 2t, because the denominator t cancels, y is equal to t squared times t minus 1. Okay, now the idea is that we have this product rule. So we're gonna get d dt of t squared y is equal to t squared times t minus 1. And then we integrate both sides. I'll be right back. All right. All right, so now we just have to take the integral. So this is going to be, so the left-hand side cancels, the integral and the derivative cancel, so we get just t squared y is equal to, and then we're going to get t cubed, the integral of t cubed minus t squared, which is t to the 4 over 4 minus t cubed over 3. And then we can divide both sides, so this becomes t2 and this becomes t1. So then y of t is equal to t squared over 4 minus t over 3 plus c. Did I get that right? Oh, you need to leave that in there? Okay. Um, okay, yeah. All right, I just was verifying that this was the solution to the homogeneous equation, and it is. Um, okay, so this one, so yeah, so apparently this e to the minus, what does that even look like? Why would I go inside if it's like a beautiful day? Come on, man. What are you talking about? What does it give you if you do? Or e, can I do this? If I do x of x, this should be fine, right? Yeah, so we can do x of, what is it, x to the minus 2. Okay, yeah, see, this gives you this weird earth function. Yeah, so it's not expressible in terms of an easy thing. Okay. What? Okay. Do they have earth in here? They do. Well, that's pretty interesting. All right, so they have another example here. The total volume of fluid is kept fixed, and the resulting differential equation for the amount of contaminant is autonomous. It can be solved by separating variables. If the total volume of fluid changes, then the differential equation is non-autonomous and must be solved using. Okay, cool. All right, let's do this example. Uh, oh wow. Okay. This is a cool problem. It feels real. That's why I like it. It's not warm enough yet, man. The product of its concentration in the pond, which is S, right? And the rate. Oh yeah. So okay. Wait, but to determine the concentration, we note that the so S is the concentration in the pond, right? Oh, S is the amount of salt. So if you divide it by the volume, okay, yeah, that makes sense. So the outflow, and because for each day, 50 goes away. So at some point, this thing's gonna be full of trash. Okay, so that's pretty simple. Okay, then they explain the domain or the yeah. Okay, and then they give us the initial condition. The autonomous, we solve it integrating factor, or is non-autonomous. Okay, cool. Whoa. Whoa. That's crazy. Okay. Using the initial condition, we find that C is that, and this is the final solution. Wow. Yeah, because the large number, 200 to the 26. So the concentration saturates, but yeah. Comparing the methods of solution for linear. Okay. You only know one method for solving linear differential equations, and you certainly save time thinking about which method to use. We have two, and each method has its advantages. Okay, trying to guess would be hard. Hence, the method of integrating factors is the only. I don't know why it would be hard to guess, but okay. Because honestly, where's the original differential equation? I don't know why that would be hard to guess. Maybe because there's a. Okay. On the other hand, consider v prime plus 0.4v is equal to 3 cos 2t. This integral can be done by hand. If you use a guessing technique. Oh. Yeah. Okay, that's a good example. So we'll do exercise 21. We'll do both of them, and then we'll see which is easier. All right. So which method is better? They give the same, but guessing is faster. We know the general solution, yeah, which senses 0. And so over the long term, all solutions converge to the periodic solution. Yeah. Okay. I feel like it does make sense what the two strategies are. So the guessing technique avoids the integration, but is only practical for certain. Most importantly, you need to understand what it means to be a linear equation and the implications of the linearity principles. It's also important that you remember the clever idea behind the development of integrating factors. Integrating factors is so clever. All right, let's freaking. It's practice time, baby. So we are going to switch over to this and get started. All right, we're just going to go through and do them. So problem 1, y prime is equal to minus y over t plus 2. So now we're supposed to integrate this by integrating factors. So the first thing to do is we're going to add this. So I'll just write this just to understand a of t. So linear equations are y prime is equal to a ty plus b of t. Okay, so a of t is equal to minus 1 over t, and b of t is equal to 2. Okay, but what we want to do is we want to make g of t. So the form for integrating factors is we're going to get y prime plus y over t plus 2. So in this case, g of t is equal to 1 over t. So it's just the inverse. We just multiply by minus 1 or whatever. Oh, is equal to. Okay, so all right, let's remember what we need to do. So we're trying to get a u of t where we end up with we're trying to end up with u y prime plus u prime y. And the way that we find u is we need du dt to be equal to u of t times 1 over t, because this is g. So, because in this equation, if we multiplied both sides of this by u of t, we would get u of t y prime plus u of t g of t y. And so we need this part to be equal to du dt. Okay, so now that we have this differential equation set up, we can actually integrate it. So it's just going to be du over u is equal to 1 over t dt. And so we know that if you integrate, you're going to get ln u is equal to ln t. So u is equal to t plus c. Okay, so now we have the integrating factor. We're going to get t plus c times y prime plus, and we can get rid of the c. They said in the book you can get rid of c. So we're just going to get t. So it's going to be t times y over t, so these cancel, is equal to 2t. So now that we have the form ty prime plus y is equal to 2t. We can rewrite this as d dt of ty is equal to 2t. Now, if we integrate both sides with respect to t, we're going to get ty is equal to t squared. So y of t is just equal to t plus c. Wait, actually, though, this is going to be plus c, so this is going to be c over t. Okay, so that's the first problem. Okay, problem 2. Wait, actually, I'm going to double check it, though. I'll double check my answers. Yep, okay, we got it right. I guess the one thing that ChatGPT said is that t cannot be equal to 0. Okay, problem 2. dy dt is equal to 3 over ty plus t to the 5. Okay. I'll be right back. Okay. So problem 2. All right. All right, so we're going to get g of t is the inverse of this. So it's going to be equal to minus 3 over ty. Or, man, for some reason I always blank out on what to do. So we need u prime equals ug. So we're going to get du over u is equal to minus 3 over t dt. And when we integrate, we're going to get minus 3 ln t plus c and ln u. So now we're going to get let me just take that to be 0, I think. So then we're going to get exp ln t cubed, t minus is going to be equal to, these cancel, u of t is equal to t to the minus 3. So now that we know that, we can multiply both sides by u of t. So we're going to get t to the minus 3 y prime minus t to the minus 3 times 3 over ty is equal to okay, so we're going to get there, let's do plus minus 3 there, just to, anyways, we're going to get plus minus 3 over t to the 4th y. Okay, so then the last part of this is d dt of t to the minus 3y is equal to t squared. So we integrate both sides with respect to t. We get t to the minus 3y is equal to this integral dt. Is that right? I'm going to double check. Yep, okay. I don't know why it says t cannot equal 0. I'm guessing just because, I mean, even in the original differential equation, t cannot be 0. Okay, that's fine. Okay, problem 3. Okay. So let me just make sure I got it right. All right. So that means that g of t all right. So then we could just set up our differential equation. So we're gonna get du dt is equal to u times 1 over 1 plus t. So now all we have to do is we need to we get ln of u is equal to the integral of 1 plus t dt. And this integral, is it not just, I'm pretty sure that this is just ln u is equal to ln 1 plus t. So then, yeah, u of t becomes exp ln 1 plus t, which just becomes plus c, which just becomes u of t is equal to 1 plus t plus c. So then, we're gonna get, oh yeah, but we let c equals 0 on the integrating factor, so we can just get rid of that. So we're gonna get 1 plus t times dy dt. So now we're gonna we're multiplying both sides by u of t now. Is equal to, oh, and these are gonna cancel. So this is gonna be minus y. Right, that makes sense because the derivative of this is just 1. Wait, hold on. Something seems, oh wait, no. This is on the other side. This is gonna be plus y is equal to 1 plus t times t squared. So we're gonna get d dt of y times 1 plus t is equal to t squared plus t cubed. We integrate, get y 1 plus t is equal to t cubed over 3 plus t4 over 4. Plus c. So we're gonna get y of t is equal to 1 over and I guess in this case, all right, let's double check our answer. Okay, cool. That's correct. All right, moving on. Number 4 is dy dt is equal to minus 2ty plus 4e minus t squared. Okay. G of t is equal to 2t. So we have, so then that means that u of t is going to be equal to then we cancel that. So u of 2t. Then we're going to get d dt. So we're just doing these fast at this point. This is going to be wait, actually, hold on. Wait, I did this wrong. Wait, it's going to be, yeah, I did this wrong. It's not this. It's e to the t squared. Because then and actually wait. Because that doesn't seem right. It's definitely e to the t squared, but what I don't understand is that if we write out the whole thing, we're going to get e to the t squared dy dt plus, oh, wait. Because we get, oh no, this is okay. Okay, so then plus e, 2t e to the t squared, um, wait, but this doesn't seem right. It is true that du is equal to u. That's true, but this has that extra. Hold on. What am I tripping out about here, man? Because this should be y prime u y prime plus um, this. If I do this simplification where I just say that d dt it's just not right though. Let me start over. Hold on. So we get dy d so let's start over. Plus 2ty is equal to 4e to the minus t squared. So then g of t is equal to 2t. So then we have, if we multiply this out, we're going to get u of t y prime plus u of t g of t y is equal to u of t 4e to the minus t squared. And the point is that if we want to rewrite this as d dt u t y of t, then we need du dt equal to g of t u of t. So this means that du dt is equal to 2tu of t. So we get du over u of t is equal to 2t dt. We integrate and we get ln of u is equal to t squared. So then we get u of t is equal to e to the t squared. So now we can rewrite the expression e to the t squared y prime plus e to the t squared times 2 t. Oh, yeah. See, that's where I messed up, is that I was putting the differential term in there, and I was putting du dt and not just u, but it's supposed to be u because we solved it so that ug equals okay, great. So then here is equal to e to the t squared times 4e to the minus t squared. So then aren't we going to just get, this becomes 1. So then we just get minus 4. Or not minus 4, just 4 is a product. Okay, so then what do we need? We need d dt e to the t squared y is equal to 4. So then we get and if we integrate both sides with respect to t, we're going to get 4t plus c is equal to e to the t squared y. So then y of t equals 4t plus c over e to the t squared. Cool. We got it right. All right. Continuing on, number 5. dy dt is equal to dy dt minus 2t 1 plus t squared y is equal to 3. So now here we want to do plus minus. So that means that g of t is equal to minus 2t over 1 plus t squared. Okay, this is going to be a fun integral because we need to integrate this. So the integral of g of t dt is equal to the integral of minus 2 t, or wait, actually no, we can do the minus here and the 2 here. 1 plus t squared dt. Let u equal 1 plus t squared. Du dt is equal to 2t. So that means that dt is equal to du divided by 2t. So it's just basic u substitution. So then what we can do is we can rewrite the integral as minus 2t over u times du over 2t. We cancel these. And then we just are left with minus ln of u, which is equal to minus ln of 1 plus t squared. So this is equal to integral of g of t dt. All right, so now that we have that, what we need is that u of t. So u of t is going to be equal to the exp of this expression. So this is going to be exp of 1 plus t squared to the minus 1. Oh, wait, there's an ln in there. ln plus c, which could be rewritten as e to the c e to the ln 1 plus t squared to the minus 1. Extra set of parentheses in there. Okay, which is equal to, so u of t is equal to, and the c's don't even matter. It's just going to be 1 over 1 plus t squared. From there, we multiply both sides by u of t. So we're going to get, well, symbolically, we're going to get u y prime plus u g y equal to 3u. So this is equal to 1 over 1 plus t squared y prime plus 1 over 1 plus t squared times minus 2t 1 plus t squared y is equal to 3 over 1 plus t squared. We really don't often have to even write this because we know that we're just going to, I mean, as long as we were able to solve the differential equation for u of t, then we should just be able to rewrite this as 1 over 1 plus t squared y is equal to 3 over 1 plus t squared. And so then we integrate dt, integrate dt. And this is going to be equal to y over 1 plus t squared is equal to, and then this integral this is equal to 3 over here with a 1 here. And then I think that this is I'm pretty sure that this is arctangent. I never remember these things, but I'm pretty sure that this is just going to be 3a tan t plus c or something like that. Or is this, I don't remember. These ones I need to refresh my memory of. But so then that would make the final solution y of t equal to 1 plus t squared times 3a tan t plus c. Let's double check because I don't know about these constants. Oh, that's correct. All right, so that is the right answer. Okay. I mean, just for the practice, let's just do number 6. Okay, number 6 is dy dt minus 2 over ty is equal to t cubed e to the t. So this is a plus minus g of t is then equal to minus 2 over t. So then that means that this is going to be minus 2 integral t to the minus 1 dt is equal to minus 2 ln t is equal to ln t to the minus 2. So then we exp that, so then we get, okay, so then u of t becomes 1 over t squared. So then we're going to get d dt of 1 over t squared, or y over t squared is equal to t to the 5th e to the t. But now we need to integrate this. So I guess one thing you need to remember is that when you see these linear equations, b of t needs to get integrated. Or not b, ub needs to be integrated. This ends up getting integrated. So if the product is like kind of hard to take, I think now that I've done so much of this, I can't even remember how to guess the solution. Maybe we'll do it by guessing next, just to, what's up, man? What's up, Riley? We just spamming homework all day, every day at this point. No time for fun. No, this is pretty fun. It's weird, though. So, wait. But yes, we need to integrate these. So we're going to get y over t squared All right. I need to figure out how to. Wait, maybe I did this wrong. Whoa. Repeated integration by parts? Tabular integration? That's actually fucking cool, man. Wow. I mean, yeah, once you have computers, you can just do stuff like that. So I think they threw this in there just to be like, do you really want to do this? All right, so let's try to guess this. All right, so if we go back and try to guess the solution, we're going to do, so the homogeneous equation is y prime is equal to 2 over ty. So now, oh wait, y prime is equal to, so now we're going to get dy over y is equal to 2 over t dt. So then we're going to get 2 ln t ln y. So then we're going to get y is equal to t squared. This is going to be yh of t is equal to t squared. Plus, or wait. This is going to be, let's just stop skipping steps. Ln of y is equal to ln of t squared plus c. So then we should get c e to the t squared. So this is the homogeneous solution. Now what we need to do with the homogeneous solution, we need to find a particular solution. Okay, so what my particular solution is going to be is I'm going to guess equal to a t b e to the t. So this derivative is going to be b a t to the b minus 1 e to the t plus, so the product, so dy p dt should be equal to, so first let's do u prime y plus y. So this is going to be yeah, a b to the b minus 1. Shoot. E to the t plus e to the t a t. Okay, so I don't know if this is going to work because we're going to have, yeah, I don't think that's going to work because you need b minus 1 equal to, I'll be right back. Okay. So this guess is no good. Why does it fail? It fails because what we need is for wait, let me. We need to guess the solution. We need to guess a particular solution to the differential equation y prime minus 2 over ty. Now, I'm going to review the notes. I totally don't remember how to freaking do this. Oh, wait. But what we're trying to do, then we're going to get. So we have this, but so if we had a, b, t to the b minus 1, e to the t, we're going to do plus minus 2 over t times y, which is a t to the b. Oh, nice. Okay, so this actually did work. Okay, because here's what we're going to get. We're going to get this becomes b minus 1. So then we're going to get a minus 2, or we're going to get ab minus 2a times t to the b minus 1 e to the t is equal to t to the 3 e to the t. So then b must be 4. So then 4a minus 2a. 2a is equal to 1. So then a equals 1/2. So that means that our particular solution, yp of t, is equal to 1/2 t to the 4 e to the t. So then our general solution is just going to be c e to the t squared plus 1/2 t to the 4th e to the t, like that. All right, I'm going to look up that solution because that's 1.8. Where's this is 1.9 number 6. Okay, so let's see. How far did I get? So I got this, so that's correct. And I multiplied both sides by it, so then I get is equal to this integral. Wait, why does the wait? What happened? Oh, you know what we did? Because we did this wrong. This is supposed to be t. That's why. T e to the t. Not to the 5. But then how do they integrate that? Excuse me. How do you integrate this then? I still don't know how to integrate that. Yeah. Okay, so the integral. Oh, so you have to do an integration by parts thing. Dude, I need to review integration by parts and just like understand the derivation because I do not get it. So okay, so anyway, so let's go down. So I don't think that this is right. I think somehow I guessed wrong. Okay, hold on. So the integral of wait, is it in frame? All right, so we're doing the integral of t e to the t dt. So we let u equal to t and v equal to e to the t, and we get the integral of wait. Wait. The integral of u dv? What? Oh, wait, hold on. Okay. So then dv dt is equal to just e to the t. So then we get dv equals e to the t dt. Okay. All right, that checks out. And so we have the identity that u dv is equal to uv minus integral v du. Okay. So this is going to be equal to t e to the t dt. Well, this is a dude. Integration by parts is weird. So this integral, which is what we originally had, is equal to t e to the t minus the integral of e to the t du. Du dt is equal to 1. So that means that du is equal to dt. So this is just dt, which is, and the integral of e to the t is just e to the t, right? So we're going to get, yeah, t minus 1 times e to the t. So this is the integral. Okay. So that, okay, so we're almost done. So the final thing is just write down the solution, which is, I think it's going to be y of t is equal to t squared times t minus 1 times e to the t. I think that, oh, where's the c? This is plus c. So this is plus c. Okay, I think that's the final thing. Yeah, okay, that's correct. And I guess they require t is not equal to 0. Wow, that one was a doozy. I'm glad they had one that requires integration by parts. I'm trying to figure out though where. Wait, hold on. I want to ask GPT how to do it via guessing, because I think my guesses were wrong. Because I guessed y p is equal to a t to the b e to the t. And then I got this form. So if I just wait. Oh, because this is just t squared. That's where it went wrong. Wait, that's one error. That's one error. And they guess a full. All right, whatever. All right, more. I don't know how many more we should do. All right, I say we just keep going. Let it ride, dude. Y prime is equal to minus y of 1 plus t plus 2. Okay, so g of t is a 1 over 1 plus t. So that means that ln u is equal to integral of 1 plus t dt is equal to ln 1 plus t plus c. So then we have u of t is equal to okay. So then 1 plus t plus c y prime. We can get rid of the c. 1 plus c y prime plus y plus okay, so then we're gonna get double check that this makes sense. G times u is gonna be just 1, and du dt is equal to 1. So we're good. Right, so now we just need to integrate 2 plus 2t dt. So we're going to get 2t plus t squared is equal to y times 1 plus t. It's because we integrate this dt, integrate this dt. So y with t is equal to oh wait, and this is Oh wait, but we need to solve the initial value problem for y of 0 is equal to 3. So then 3 is equal to 0 plus c over 1. So then this just becomes 3. Oh, I guess you end up with t squared plus 2t plus 3 is equal to t plus 1. Wait, what? No, I don't know. This is correct, though. So, okay, so g of t is equal to minus 1 over t plus 1. So then we get minus ln t plus 1. So then we get minus t plus 1. U of t is equal to this. So then we get d dt minus t minus 1 times y is equal to 4t squared plus 4t times minus time. Wait. No, this is 1 over. So this is going to be d dt 1 over, or y over t minus t plus 1 is equal to so then we're going to get 2t squared plus c is equal to y over t plus 1. Okay. So I think that's. Oh wait, but then let's just double check. So, um, so 2 times so y1 equals 10. So we're gonna get 10 is equal to 2 times 2 plus c. So 4 plus 2c equals 10. C equals 3. So then this just becomes a 3. Cool. All right, this is right. And wait, how did we get this t is greater than minus 1 thing? Oh yeah, because the ln somewhere. Because ln t plus 1 must be defined t is greater than I've been doing this almost 2 hours now. Maybe we'll jump ahead to some of the harder ones. Let's try to do one from every section. Okay, so let's try 13. Okay, 13 is, okay, so the problem is, since the method of integrating factors involves computing two integrals, in practice it is frequently impossible to reach a formula for the solution that is free of integrals. For these exercises, determine the general solution of the equation and express it with as few integrals as possible. All right, so y prime is equal to sine t y plus 4. So y prime plus minus sine t y is equal to 4. G of t is equal to minus sine t. That means that ln u is equal to the integral of minus the sine. So I'm pretty sure that the integral of just normal sine is cos, right? Hold on. I always have to do this. So cos starts out like this. But then the slope goes down. So that means that d cos dx is equal to minus sine, because it starts at 0, but then it slopes down. But sine goes up. So that means that the integral of, so then that means that d sine is equal to cos. So I always forget this. So it goes like, so in terms of d, cos to minus sine, then the derivative of that becomes minus cos, then finally to sine, and then back around. So if we want to go the other way, the integral of sine is going to be minus cos. So we're going to get ln of u is equal to minus cos t plus c. So that's just these cancel. I'm never gonna remember this. I don't know how people remember that. I have to always draw the picture. So what's next though is figuring out. So then we're gonna get u to the u of t is equal to x cos t. So we're gonna have x cos t. That's u. So then d dt of this y is equal to. So wait, hold on. Let me think about this though, because wait, did I do this wrong? No, I did this so wrong, dude. What? Wait, did I? We're gonna get u prime is equal to gu, but then this goes around. So then we just have to integrate u dt. Yeah. So okay, I think we did it right. So now we just have to It's going to be 4x cos t. Now we just have to integrate this. But I don't know how you integrate x cos. What does that even look like? That's pretty cool. So then my guess is that this actually does have an indefinite integral. So we're going to get x cos t times y is equal to integral 4 times the integral of x cos t dt. How do we integrate this? Does not have an antiderivative that can be written in terms of elementary functions. However, one clean way to express its indefinite integral is via the modified Bessel function. What is a Bessel function? Man, all the you know what's so funny is like, oh man, all this like functional, these people that have discovered these functions, it's just like you could do this, you could find this stuff with a weird structure. It's not like that crazy, you know. It's just interesting. Okay, whatever. So I think that this is the solution, is that we just have y of t is equal to 4 times this. We have 1 over x cos t time 4 over x cos t times the integral of x cos t dt. So I think that this is as good as you can get. Why do they do a change of variables? So this is almost right. The only thing that they did was that it's they did like a e to the minus cos t times c plus 4 integral of this. And they did some weird change of variable thing, but I don't know what that's about. So there you get a general there at least the c, because if you're gonna do a general solution, you need a c somewhere, and then you collapse the c later. But I don't know. Maybe it's the same. That one was good though. I like that one because it was the first one with a trig in it. All right, let's just try one more. $18 looks brutal. All right, let's do 18. Probably not in frame. Okay. 18 is y over the square root of t cubed minus 3 plus t. So what we're going to get is so then g of t is equal to oh, this integral looks gnarly, dude. How do you integrate that? I guess you would just say that u of t is equal to the integral of g of t, or x of the integral of g dt. Okay. So then whatever u of t is, y of t is going to be equal to 1 over u of t times c plus, c comes from this side. And then what we're going to have here is the integral of t times u of t dt. I'm pretty sure that this is the whole thing. So this is 2 unevaluated integrals. I wonder if you can do better, but that seems like a crazy integral to take. I don't know how to do that integral. Because u substitution is not going to give you anything, I think. Let's see what Oh, hypergeometric 2F1. What the hell is that? Yeah. Okay, so what even is that? I don't know anything about hypergeometric functions. The Gaussian or ordinary hypergeometric function is a special function represented by the hypergeometric series. I don't know what that is. It includes many special functions as a specific or limiting case. It is a solution of a second-order linear differential equation. Every second-order linear ODE with 3 singular points can be transformed into this equation. That's wild. There is no known system for organizing the identities. Indeed, there is no known algorithm that can generate all identities. There are a number of different algorithms that are known to generate different series of identities. The theory of algorithmic discovery of identities remains an act. Dude, that's freaking cool, man. What the heck? Oh, what the hell, dude? All this stuff seems to really, I mean, it all, whenever you get into this functional analysis stuff, it always just, you need an algebraically closed field. So it always naturally ends up in complex analysis, I guess. But I don't know. That's crazy, man. So anyways, you have to leave it as 2 unsolved integrals. Because, yeah. I don't know why they do the change of variables. All right. Well, that was fun. Learn something new. Hypergeometric functions. So I wonder, can you evaluate, like, let's say we did t from 0 to 10. Do we get a number out? You get a complex number out. Yeah, I don't know anything about complex analysis. That's weird. How can the area under a curve be a complex number? That's crazy, man. Dude, people have studied polynomials so much, it's crazy. Confluent. All right, so I'm curious. Is it like complex analysis, functional analysis? The theory of special functions, dude. Yeah, see these people that like special functions, I bet it's like how I like integer sequences. the list of functions. Wow, what a terrible notation. If this means this, then this should not mean this. It should mean that. That's so stupid. Terrible notation. Whatever. Trig and X were formalized and unified by the 18th century. All right, let's look at the list, dude. Polynomials, rational functions, roots, transcendentals are not algebraic. X hyperbolic. I never really understood hyperbolic functions. Yeah. Logs, powers. Wait. How is a power function not what is x secant? I've never even heard of these. That's crazy. Heckover sign? Haver cosine? Wait. Heckover sign? What, dude, what are we talking about? Heckover cosine. Oh my god. Special functions that are. This is a freaking cool Wikipedia page, man. Oh, these are all like discrete kind of things. I will say though, complex analysis is like truly, it's got the prettiest pictures, man. Yeah, see, I Lambert W. I've seen this all over the place, but I don't know what this is. Anyways, it's all right. Pretty cool though. All right, so yeah, you needed two integrals to do that one. 19 is going to be part of our homework. I'm going to do 19. All right. For what a Okay, so what we're going to do is y prime plus minus a t y is equal to 4e to the minus t squared. Are we in frame? Okay. So this means that g of t is equal to minus a t. So then we're going to integrate this dt, and we're going to get minus a over 2 t squared is equal to the integral of g of t dt. So now we're going to get u of t is equal to x minus a t squared over 2. So then we're going to get d dt of y times x minus a t squared over 2 is equal to 4 times, it's going to be x of a minus a t squared over 2 times 4 e to the minus t squared. So wait, so if we were to factor out so this should be x 4x times minus t squared one plus a over 2. And the thing to note that if that the main thing to note is that x of minus t squared is non-elementary. This integral is not chill. Not a chill integral, this one. I think it's like an earth. So so we need a equal to minus 2. That makes this 4 exp 0 is equal to this, which is and this you end up integrating with dt, so this just becomes yx. Wait, did we already do all that? No, I don't think so. Um, oh wait, but then this becomes -2, right? Wait. Oh yeah, no, this is right. You just get rid of this. $22 would be pretty good to do, but I think we're gonna just uh, end it here. We did. Let's see how many problems did we do. There's 2 here. 3, 4, 5 plus 6. We did 11 problems. That's pretty good. All right. So that's integrating factors. They're actually pretty cool when you get good at them.